In computing, a Uniform Resource Identifier is a string of characters used to identify the name of a resource. Such identification enables interaction with representations of the resource over a network, typically the World Wide Web, using specific protocols. Schemes specifying a concrete syntax and associated protocols define each URI. The most common form of URI is the Uniform Resource Locator, frequently referred to informally as a web address. More rarely seen in usage is the Uniform Resource Name, which was designed to complement URLs by providing a mechanism for the identification of resources in particular namespaces. Relationship between URIs, URLs, and URNs. A Uniform Resource Name functions like a person's name, while a Uniform Resource Locator resembles that person's street address. In other words, the URN defines an item's identity, while the URL provides a method for finding it. URLs equals. A URL is a URI that, in addition to identifying a web resource, specifies the means of acting upon or obtaining the representation of it, that is specifying both its primary access mechanism and network location. For example, the URL http example.org main page refers to a resource identified as main page whose representation, in the form of HTML unrelated code, is obtainable via hypertext transfer protocol from a network host whose domain name is example.org. URNs equals. A URN is a URI that identifies a resource by name in a particular namespace. A URN can be used to talk about a resource without implying its location or how to access it. The International Standard Book Number System for uniquely identifying books provides a typical example of the use of URNs. ISBN 0-486-27557-4 cites unambiguously a specific edition of Shakespeare's play Romeo and Juliet. The URN for that edition would be URN, ISBN 0-486-27557-4. To gain access to this object and read the book, its location is needed, for which a URL would have to be specified. Conceptual distinctions technical publications, especially standards produced by the IETF and by the W3C, normally reflect a view outlined in a W3C recommendation of 2001, which acknowledges the precedence of the term URI rather than endorsing any formal subdivision into URL and URN. A URL is simply a URI that happens to point to a physical resource over a network. However, in non-technical contexts and in software for the World Wide Web, the term URL remains widely used. Additionally, the term web address often occurs in non-technical publications as a synonym for a URI that uses the HTTP or HTTPS scheme. Such assumptions can lead to confusion. For example, when viewing XML source, the normal means of identifying unique XML vocabularies within an XML document is to declare XML namespaces whose names are URIs that begin with HTTP and use the syntax of a genuine domain name followed by a file path, but which have no need to point to any specific file locations that actually exist. While most URI schemes were originally designed to be used with a particular protocol, and often have the same name, they should not be referred to as protocols. Some URI schemes are not associated with any specific protocol and many others do not use the name of a protocol as their prefix. Syntax. The syntax of generic URIs and absolute URI references was first defined in Request for Comments 2396, published in August 1998, and finalized in RFC 3986, published in January 2005. A generic URI is of the form scheme. User, password at host, port, /path. Query, fragment. It is composed of the following components. The scheme consists of a sequence of characters beginning with a letter and followed by any combination of letters, digits, plus, period, or hyphen. Although schemes are case-insensitive, the canonical form is lowercase and documents that specify schemes must do so with lowercase letters. It is followed by a colon. Examples of popular schemes include HTTP, FTP, mail-to, file, and data. URI schemes should be registered with the Internet Assigned Numbers Authority, although non-registered schemes are used in practice. 2 slashes, this is required by some schemes and not required by some others. When the authority component is absent, the path component cannot begin with 2 slashes. An authority part, comprising an optional authentication section of a username and password, separated by a colon, followed by an @ symbol, a host, consisting of either a registered name, or an IP address. IPv4 addresses must be in decimal notation, and IPv6 addresses must be enclosed in brackets. For URIs relating to resources on the World Wide Web, some web browsers allow .0 portions of decimal notation to be dropped and even raw integer IP addresses to be used. An optional port number, separated from the hostname by a colon. A path, which contains data, usually organized in hierarchical form, that appears as a sequence of segments separated by slashes. Such a sequence may resemble or map exactly to a file system path, but does not always imply a relation to one. The path must begin with a single slash if an authority part was present, and may also if one was not, but must not begin with a double slash. An optional query, separated from the preceding part by a question mark, containing a query string of non-hierarchical data. Its syntax is not well defined, but by convention is most often a sequence of attribute value pairs separated by a delimiter. An optional fragment, separated from the preceding part by a hash. The fragment contains a fragment identifier providing direction to a secondary resource, such as a section heading in an article identified by the remainder of the URI. When the primary resource is an HTML document, the fragment is often an id attribute of a specific element, and web browsers will scroll this element into view. Strings of data octets within a URI are represented as characters. Permitted characters within a URI are the ASCII characters for the lowercase and uppercase letters of the modern English alphabet, and the Arabic numerals. Octets represented by any other character must be %encoded, as in %26 for an ampersand. Examples the following figure displays 2 example URIs and their component parts. Hierarchical part, an a euro 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 authority path, an a euro 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 ABC, username password at example.com 123 data key equals value frigid 1 a euro 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 a schemed user information host port query fragment. Example mumble monitoring echidna a euro 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 a scheme path. History equals naming, addressing, and identifying resources equals URIs and URLs have a shared history. In 1994, Tim Berners-Lee unregistered trademark S proposals for hypertext implicitly introduced the idea of a URL as a short string representing a resource that is the target of a hyperlink. At the time, people referred to it as a hypertext name, or document name. Over the next 3.5 years, as the World Wide Web's core technologies of HTML, HTTP, and web browsers developed, a need to distinguish a string that provided an address for a resource from a string that merely named a resource emerged. Although not yet formally defined, the term Uniform Resource Locator came to represent the former, and the more contentious Uniform Resource Name came to represent the latter. During the debate over defining URLs and URLs, it became evident that the two concepts embodied by the terms were merely aspects of the fundamental, overarching notion of resource identification. In June 1994, the IETF published Berners-Lee's RFC 1630, the first RFC that acknowledged the existence of URLs and URLs, and, more importantly, defined a formal syntax for universal resource identifiers, a URL-like strings whose precise syntaxes and semantics depended on their schemes. In addition, this RFC attempted to summarize the syntaxes of URL schemes in use at the time. It also acknowledged, but did not standardize, the existence of relative URLs and fragment identifiers. Refinement of specifications. In December 1994, RFC 1738 formally defined relative and absolute URLs, refined the general URL syntax, defined how to resolve relative URLs to absolute form, and better enumerated the URL schemes then in use. The agreed definition and syntax of URLs had to wait until the publication of RFC 2141 in May 1997. The publication of RFC 2396 in August 1998 saw the URI syntax become a separate specification, and most of the parts of RFCs 1630 and 1738 relating to URIs and URLs in general were revised and expanded by the IETF. The new RFC changed the significance of the U in URI. It came to represent uniform rather than universal. In December 1999, RFC 2732 provided a minor update to RFC 2396, allowing URIs to accommodate IPv6 addresses. Sometime later, a number of shortcomings discovered in the two specifications led to the development of a number of draft revisions under the title RFC 2396 bis. This community effort, coordinated by RFC 2396 co-author Uri Fielding, culminated in the publication of RFC 3986 in January 2005. This RFC, as of 2009, the current version of the URI syntax recommended for use on the Internet, renders RFC 2396 obsolete. It does not, however, render the details of existing URL schemes obsolete. RFC 1738 continues to govern such schemes except where otherwise superseded. A RFC 2616, for example, refines the HTTP scheme. Simultaneously, the IETF published the content of RFC 3986 as the full standard 66 Automand Principe Dobras, reflecting the establishment of the URI generic syntax as an official Internet protocol. In August 2002, RFC 3305 pointed out that the term URL has, despite its widespread use in the vernacular of the Internet-aware public at large, faded into near obsolescence. It now serves only as a reminder that some URIs act as addresses because they have schemes that imply some kind of network accessibility, regardless of whether systems actually use them for that purpose. As URI-based standards such as Resource Description Framework make evident, resource identification need not suggest the retrieval of resource representations over the Internet, nor need they imply network-based resources at all. In 2001, the W3C's Technical Architecture Group published a guide to best practices and canonical URIs for publishing multiple versions of a given resource. For example, content might differ by language or by size to adjust for capacity or settings of the device used to access that content. The semantic web uses the HTTP URI scheme to identify both documents and concepts in the real world, a distinction which has caused confusion as to how to distinguish the two. The TAG published an email in 2005 on how to solve the problem, which became known as the HTTP Range 14 resolution. The W3C subsequently published an interest group note titled Cool URIs for the Semantic Web, which explained the use of content negotiation and the HTTP 303 response code for redirections in more detail. Uri reference. A Uri reference may take the form of a full URI, or just the scheme-specific portion of one, or even some trailing component thereof, even the empty string. An optional fragment identifier, preceded by, may be present at the end of a Uri reference. The part of the reference before the indirectly identifies a resource, and the fragment identifier identifies some portion of that resource. To derive a URI from a URI reference, software converts the URI reference to absolute form by merging it with an absolute base URI according to a fixed algorithm. The system treats the URI reference as relative to the base URI, although in the case of an absolute reference, the base has no relevance. The base URI typically identifies the document containing the URI reference, although this can be overridden by declarations made within the document or as part of an external data transmission protocol. If the base URI includes a fragment identifier, it is ignored during the merging process. If a fragment identifier is present in the URI reference, it is preserved during the merging process. Web document markup languages frequently use URI references to point to other resources, such as external documents or specific portions of the same logical document. Uses of URI references in markup languages equals, in HTML, the value of the src attribute of the img element provides a URI reference, as does the value of the if attribute of the a or link element. In XML, the system identifier appearing after the system keyword in a DTD is a fragmentless URI reference. In XSLT, the value of the if attribute of the XSL import element instruction is a URI reference. Likewise, the first argument to the document function examples of absolute URIs equals HTTPS example org Uri Equivalents resource txt FTP example.org/ resource.txt earn ISSN 1535-3613 examples of URI references equals HTTPS example org Uri Equivalents resource txt example org Uri Equivalents resource txt Uri Equivalents resource txt relativito resource txt /resource txt /resource txt frag01 resource txt frag01 URI resolution. To resolve a URI means either to convert a relative URI reference to absolute form, or to dereference a URI or URI reference by attempting to obtain a representation of the resource that it identifies. The resolver component in document processing software generally provides both services. One can regard a URI reference as a same document reference, a reference to the document containing the URI reference itself. Document processing software can efficiently use its current representation of the document to satisfy the resolution of a same document reference without fetching a new representation. This is only a recommendation, and document processing software can alternatively use other mechanisms to determine whether to obtain a new representation. The current URI specification as of 2009, RFC 3986, defines a URI reference as a same document reference if, when resolved to absolute form, it equates exactly to the base URI in effect for the reference. Typically, the base URI is the URI of the document containing the reference. XSLT 1.0, for example, has a document function that, in effect, implements this functionality. RFC 3986 also formally defines Uri equivalents, which can be used to determine that a URI reference, while not identical to the base URI, still represents the same resource and thus can be considered to be a same document reference. RFC 2396 prescribed a different method for determining same document references. RFC 3986 made RFC 2396 obsolete, but RFC 2396 still serves as the basis of many specifications and implementations. This specification defines a URI reference as a same document reference if it is an empty string or consists of only the character followed by an optional fragment. Relation to XML namespaces. XML has a concept of a namespace, an abstract domain to which a collection of element and attribute names can be assigned. The namespace name identifies an XML namespace. However, the namespace name is generally not considered to be a URI, because the URI-ness of strings is, according to the URI specification, based on their intended use, not just their lexical components. A namespace name also does not necessarily imply any of the semantics of URI schemes. A namespace name beginning with HTTP, for example, may have nothing to do with the HTTP protocol. Initially, the namespace name could match the syntax of any non-empty URI reference, but the use of relative URI references was later deprecated by the W3C. A separate W3C specification for namespaces in XML 1.1 permits internationalized resource identifier references to serve as the basis for namespace names in addition to URI references. See also: Notes, Citations, References, External links. URI schemes. A EuroIANA-maintained registry of URI schemes, URI schemes on the W3C Wiki, Architecture of the World Wide Web, Volume 1, A Section 2, Identification. A Euro by W3C, W3C URI clarification.